Welcome back, team. Today, we are elevating our RG pipelines by tackling one of the most powerful optimization techniques, reranking. Specifically, we will master cross-encoders and the Cohere Rerank API to achieve unparalleled retrieval precision. Let us get started. Let us begin by distinguishing between retrieval and ordering. In a standard RAG pipeline, our first step is to quickly fetch a broad set of candidate documents from our vector database. However, hybrid or semantic retrieval focuses primarily on how documents are retrieved, whereas reranking focuses strictly on how they are ordered after that initial retrieval. Standard embedding models act as a blunt instrument. They are incredibly fast, but often lack the nuanced understanding required to perfectly match a complex query to the right paragraph. Reranking acts as a fine-toothed comb. We take that initial pool of, say, 20 documents and apply a highly sophisticated model to rescore them, pushing the absolute best candidates to the top. This ensures our LLM context window is filled with high-value information, not just semantic approximations. Look at this flowchart to visualize the pipeline. On the left, our user query hits the vector database. The initial retrieval gives us our top 20 candidates. Notice the transition. This initial batch is fast but noisy. Instead of sending all 20 directly to the LLM, we insert our re-ranker model as a strict filter. It evaluates the batch, reorders it, and isolates the top 3 ordered docs with extreme precision. Only these top-tier documents are allowed to reach the final LLM generation phase. To understand re-ranking, we must understand the engine behind it, the cross-encoder. When you index documents into a vector store, you use a bi-encoder. A bi-encoder processes the query and the document completely independently, turning them into isolated vectors. This is fast, but it prevents the model from understanding how the words in the query relate to the words in the document. Cross-encoders fix this. These are specialized transformers that take 2 textual sequences, the user's query and a specific document chunk, at the exact same time. Because they are processed together, the transformer self-attention mechanism can compare every single word in the query against every single word in the document chunk. The output is a highly accurate similarity score between 0 and 1. This deep, word-by-word comparison is what unlocks true precision. This architecture diagram perfectly illustrates the cross-encoder difference. Notice how both the query text and the document chunk text are concatenated into a single input sequence. They flow together into the deep transformer layers. Inside that pink node, the self-attention mechanism is heavily cross-referencing the query against the document. Finally, the classifier head outputs a single, highly reliable float value between 0.0 and 1.0, representing true contextual relevance. As senior engineers, we must always discuss trade-offs. If cross-encoders are so incredibly accurate, why don't we just use them for the entire database search? The answer is computational cost. Standard embeddings are pre-computed and stored. Searching them is just a cheap mathematical distance calculation. Cross-encoders, however, must be run dynamically at query time because they require the query and the document to be paired. If you had a database of 1 million documents, running a cross-encoder inference 1 million times for a single user question would take hours and melt your servers. This is why we use a 2-stage architecture. We leverage the cheap, fast bi-encoder to whittle the 1 million documents down to just 20. Then we apply the heavy, expensive cross-encoder only to those 20 candidates. We get the speed of the first stage and the extreme accuracy of the second. Look at this trade-off chart. The bars represent speed and scale, while the line represents accuracy and computational cost. The bi-encoder excels at processing massive scale rapidly, but its accuracy line is lower. The cross-encoder, conversely, handles a very small scale, but its accuracy and computational cost spike dramatically. Pairing them bridges the gap perfectly. Hosting and maintaining your own open-source cross-encoder models, like BG or RankLLM, requires serious GPU infrastructure and MLOps expertise. If your team needs enterprise-grade precision immediately without managing infrastructure, the Cohere Rerank API is the gold standard. Cohere has built a commercial, API-based cross-encoder solution that delivers excellent quality across over 100 languages. You simply send it your query and your list of retrieved text chunks, and it returns them perfectly ordered with relevance scores. The beauty of this in the LangChain ecosystem is the seamless integration. LangChain treats reranking as a form of document compression, utilizing the contextual compression retriever. This means you can wrap your existing vector store retriever with Cohere's reranker without having to rewrite the rest of your application architecture. This integration flow shows how LangChain abstracts the complexity. Your base retriever pulls the initial top 20 documents. These flow into the contextual compression retriever, which acts as a manager. It sends the payload securely out to the Cohere Rerank API. Cohere does the heavy lifting, scores the documents, and returns them to the manager, which slices off everything but the top 3 to send to your LLM. Let us walk through the exact code to implement this. It is remarkably straightforward. First, we import Cohere Rerank from LangChain.retrievers.document compressors and contextual compression retriever from LangChain.retrievers. We initialize our compressor by calling Cohere Rerank and passing top n equals 3. This parameter is critical. It tells the API that even though we might send it 20 documents, we only want the absolute best 3 returned. Next, we create our wrapper by instantiating the contextual compression retriever. We pass it 2 arguments, our base compressor, which is the Cohere object we just made, and our base retriever, which is our standard vector store search. From this point on, you simply call .getRelevantDocuments on the new compression retriever, and the entire 2-stage pipeline executes automatically under the hood. This class diagram demonstrates the composition. The contextual compression retriever is the primary orchestrator class. It literally contains 2 objects, the FAISS retriever, our vector store, to fetch the initial data, and the Cohere Rerank compressor to score and filter it. When you call getRelevantDocuments on the orchestrator, it internally triggers the vector search and immediately pipes those results into the compressDocuments method of Cohere. Let's apply this to a real-time, highly impactful use case, legal compliance auditing. Imagine you are building an agent to audit massive, 500-page vendor contracts. The user asks, what is the required timeline for data breach notifications? If we only use a standard vector database, the semantic search will grab everything vaguely related to data and breach definitions, general liabilities, even marketing fluff. The exact clause mentioning 48 hours might be buried at rank 15 and completely missed by the LLM. By injecting a cross-encoder or Cohere Rerank, we change the game. We fetch those top 30 noisy chunks, but then the reranker deeply analyzes the specific relationship between the concept of a timeline in our query and the 48 hours text in the document. It thrusts that exact, critical clause to rank number 1, guaranteeing the LLM gives a legally accurate answer. Follow the audit trail here. The query enters the vector search, which mistakenly puts a generic breach definition at rank 1, burying our target clause at rank 15. The reranker engine intercepts this list. Using deep contextual analysis, it flips the order, ensuring the 48-hour clause is elevated to rank 1. The legal LLM expert receives the perfect context to synthesize a compliant answer. As we wrap up, we must discuss how to prove our reranker is actually working. Standard evaluation metrics don't work well here. Because reranking is entirely about ordering, we must use position-aware metrics, specifically recall at K. Recall at K measures whether the true, relevant documents successfully made it into the top K positions that we actually feed to the LLM. If your target document moves from rank 20 to rank 2 after applying Cohere, your recall at 3 skyrockets. The final verdict, yes, adding cross-encoders or API-based rerankers increases system latency and computational cost. However, if your application requires factual, enterprise-grade precision, it is absolutely mandatory. I invite you to like this video, subscribe to our channel, and immediately visit quicktechie.com for premium certification prep. We offer extensive Q&A banks, full ebooks, audiobooks, full-length training, and interview guides to take your AI career to the next level. See you there. Our final chart shows the dramatic impact of this technology on our evaluation metrics. On the x-axis, we have base RAG versus RG with Cohere Rerank. On the y-axis, we track our recall at 3 score. The base RAG only hits about 45%, meaning over half the time, our best data is missed by the LLM. But with the reranker active, our score jumps to 92%, ensuring our agent almost always has the exact facts it needs.
Welcome to quicktechie.com. So just type in quicktechie.com here. Then you can go through the material which is provided by quicktechie. So we have first of all video courses which you can go here and you can find the various video courses across the technologies as well as finance domain. So if you see in Microsoft, we have 8 programs currently running. Next, you can go through the ebooks available. So all the ebooks which are in PDF format today, and you can download this. So let me go through Microsoft certification ebooks. You can click on any of this and you can see this is the PDF available for you to download. So these are the premium ebook mostly available on quicktechie.com platform only. Now the second part is exam simulator. As we primarily focus on the all technology companies and finance domain certification preparation material, so this is company wide listed here and you can go through this. So let me go through the Microsoft one again. You can see this is our all Microsoft related certification. AB 730 exam, if you open it, so you can see here this, and all the practice papers are available here. Today we have a 5 practice paper. So click on the first practice paper, it would load the questions. You can answer this question. This is way you can answer it and you can move to the next question. Now third material we wanted to highlight is an audiobook. So we started recently with the audiobooks as well, which you can listen on the go, and various technology wise ebooks are available. And at the last, this is our alumni. These people who are subscribing to our courses and this platform, they are all listed here. And at the end, I wanted to tell you, if you find any course or training or certification preparation material which you want to get us prepared for yourself, please put on the comment section. If you're watching on YouTube, on Udemy, or on this platform itself, quicktechie.com, then please put the comment, or you can even send an email to using this contact us options here. You can directly do the WhatsApp message. You can call us on this numbers as well.